We know it couldn't have formed in that orbit around Neptune. It had to come from somewhere else. And a wonderful clue to where it came from is the nearby neighbor, Pluto.
Pluto is a dwarf planet in the nearby Kuiper Belt. It's only 200 miles smaller than Triton. But it's not just size that makes these two bodies similar. It's their composition.
Triton is actually most similar to Pluto. It has a similar amount of rock in its interior. It has a similar surface composition with a lot of nitrogen and methane. It really looks like a Pluto-like world, but it just happens to be orbiting a planet instead of orbiting the sun.
If Triton is like Pluto, perhaps it also started life in the Kuiper Belt. Could it have been captured by Neptune's gravity, pulled into the gas giant's orbit?
It's not easy to capture a moon into orbit around a planet. It's not natural for a body to come close to another world and just spiral in. You've somehow got to put on the brakes when it's close in.
For Neptune to capture Triton, Triton had to be slowed down. But how? Again, Kuiper Belt objects hold a clue. Many of the largest are binary pairs, two worlds orbiting each other, like Pluto and its large moon Charon. Perhaps Triton was one of a pair as well. If Triton was in orbit with a partner, each of the pair would travel at different speeds. This speed difference is key.
Triton's velocity is just a little bit slower as it's orbiting its companion. It's slow enough that it could actually get captured by Neptune, while that other one would speed off across the solar system.
Triton's original dance partner is flung out away. Triton has a new, much bigger companion, Neptune. But these unlikely partners are dancing out of sync. Capture explains the backwards orbit. But there's an even stranger mystery to solve. On a moon like Triton, we'd expect to see heavily cratered terrain, the hallmark of geologically dead worlds. Instead, Voyager 2 reveals a world that's startlingly alive.
I think one of the most amazing discoveries of the entire Voyager mission is that when we flew past Triton, we saw these jets of liquid nitrogen coming up out of the surface. We had no idea that this tiny little cold world out there would still be alive.
Smooth icy plains cover the surface. Geysers of nitrogen punch up through the crust and spew black dust 5 miles into the sky. Triton's surface is a frosty 200 degrees below freezing. Where is the heat coming from to drive these surface features? The answer lies with Neptune's capture of Triton. Triton's orbit is circular, but it was once elliptical. As Triton moved closer in and farther away, it would have been repeatedly squashed and stretched by Neptune's gravity.
That would generate massive amounts of friction inside of Triton. Might well have completely melted Triton due to those forces, and as that happened, it would have acted as a brake. All that friction would have circularized Triton's orbit and left it in the orbit that we see today.
This change in orbit is what gives Triton its heat. The surface of Triton froze over, but the moon still retains some of this warmth deep below the icy shell. Astronomers think there is enough heat to melt ice into water, forming an underground liquid ocean on a world 3 billion miles from the sun. Liquid water, heat. There's one question that's impossible not to ask. Could there be life?
If there's a source of energy on Triton, then perhaps there's a form of life that figured out how to take advantage of that energy source.
Neptune's moon, Triton, might be alive, But Uranus's moons are even stranger. They have a neat trick to cheat death entirely.